This is page 101 of the IB book. Incredible book. All right. This is the first complicated rule you have covered. We're going to cover the product rule and the quotient rule. Okay? I want you to look at this notation. So we're taking the derivative of the product of two functions. Okay? So, but as complicated as a rule as this is, sometimes it's better to just multiply it out instead of using the product rule. But there will be times when you don't have a choice. Okay? So it's f of x times g of x. And what you're going to do is you're going to keep one of the functions constant while taking the derivative of the other, plus, and then you switch the roles. So here, f is remaining constant while you're taking the derivative of g of x, plus keep the g of x constant times the derivative of f of x. Now, notice it says first times the derivative of second plus second times the derivative of the first. The order doesn't really matter as long as you switch the roles between the two parts. All right, so here, in first example, you have two functions. You have x and you have sine of x. So that's my product. It's x times sine of x. So when I take the derivative, so it's y prime. So take, it says here, the first function. So the first function is x times the derivative of the second function. So just write the first function. And what's the derivative of sine? Cosine x. Plus, now what's the derivative of x? 1. So it's 1. And I'm going to write the 1 for emphasis here. Times, and you just keep the other one. Keep the other function. So that's it. So I kept x constant, and then took the derivative of sine. That's how I got cosine x. Plus, now I took the derivative of x, which is 1, and times the second function, sine x.
What's it after y1?
After who?
y1.
Equal sign.
Or y prime, sorry.
Equal sign.
Wait, so, like, we're finding derivative, but what does the product rule do? Like, what does that help us, like, find?
You take the derivative of products. A product is when you have two things being multiplied together. So you have x times sine x. You don't have a rule for finding x sine x without finding the derivative of x sine x without the product rule.
Really?
Yes.
Because you can do sine x without sine x times x.
You have a derivative finding the derivative of x. You have a rule for finding the derivative of sine x. But you don't have a rule for x times sine x without product rule. Blake.
I looked at C.
Yeah.
And so I was going to keep 2x as the constant, but
Okay.
it doesn't stay the same.
Right.
So do you just keep it, like do you add an x to the minus 2? Or what would you do?
Okay, there's two 2's in here, so it's kind of confusing what you're trying to say. How about I do the problem?
All right.
All right. Okay, so I'm doing C.
Okay.
So when I take the derivative, now there is a product here, 2x cosine x,
Yeah.
right? But there is no product here. So 2 sine x does not require the product rule, while 2x cosine x does require the product rule. Yes?
What about like 2 and sine x?
Okay, that's the constant multiple rule. So even though it is a product, because 2 is too simple of a function, we don't need a special rule for that.
So it has to
Oh,
be
we do have a special rule, and we've already covered that rule.
So it has to be a variable.
Yeah. So here, so I'm going to do 2x times cosine x. So if I follow the pattern up here, I'm going to keep the 2x constant, so it's 2x. And then times the derivative of cosine, which would be negative sine. And I'm going to go ahead and put that in front of the 2x.
It's negative sign?
Yeah, derivative cosine is negative sine. So I've done 2x times the, so I've done, keep the 2x times the derivative cosine is the negative sine. Now I do plus, and I'm going to take the derivative of 2x, which is 2, and keep the cosine constant.
Wait, I have a question.
Yes.
So I got the first part, but I thought, like, if you take the derivative of the first,
The 2x,
Oh, I get it.
and then after,
keep the cosine.
I understand. I get it now.
Now, so that is the derivative of 2x cosine x. So I have not taken the derivative of minus 2 sine x yet. So the derivative of minus 2 sine x is minus 2 cosine x. Because the derivative of sine is cosine. And the 2 just comes further out. Even though it's multiplication, since it is just a constant and not a function like 2x, it just comes further out. The 2 comes further out.
Right.
However, if you really want to practice product rule, you could do the product rule on that. What's the derivative of 2?
0.
0. So whatever came out of that, it's going to wipe it out anyways.
That's what I had. I just had minus 0.
So it'd be minus 0 minus 2 times cosine x.
Yeah.
Yeah, that'll work. Alright, I'm going back to do B. So B is an example where it's probably easier to multiply it out instead of using the product rule. So I'm going to do this one twice. I'm going to take the derivative using the product rule and take the derivative by multiplying it out. Okay? So this one, I'm going to do product rule. So g prime of t equals 7t squared. And what's the derivative of t minus 5? 1. So it's times 1, so I'm not going to bother to write the 1. Plus, now take the derivative of 7t squared, which would be 14t, and keeping the t minus 5. So this is not very pretty, and you will probably have to simplify that.
Wait, Mr. Schweitzer.
Yes.
Wouldn't the 7 squared t plus 14 be in parentheses?
Sure. If you want to use parentheses, that's fine.
Wait,
What aren't you?
Because I don't want to.
where's the 1? Like plus 1? The t minus 5.
Alright, so I really need parentheses when there's a sum or difference. When it's a product, I usually don't need the parentheses. But if you put the parentheses, it's not wrong.
You're not big. Where would you put parentheses?
So that by itself, you can put parentheses there and put parentheses there.
Oh, wait.
But not 7t squared plus 14t and that in
Why
parentheses.
not?
Because that's the two parts of the product rule.
Oh, really?
This is the first part and this is the second part, so they're separate.
That makes sense.
Right. Now let's do it by just multiplying it out. So if I multiply this out, so doing the algebra over here, that's going to be 7t cubed minus 35t squared. Yeah? And then when I take the derivative, that's going to give me 21t squared minus 70t.
Oh, yeah.
Okay.
Which is a better option than the first one. So sometimes it's better to multiply it out and then take the derivative than using the product rule.
Do we take the derivative of that, or do we just leave
Okay, this is the derivative. So is this. But if you look, it's 7t squared. If you distribute that 14t, that becomes 14t squared, right?
Yeah.
So 7 plus 14 is 21. So there's the 21t
it?
squared.
That's how I did it. I didn't go back and plug it in.
Right. 14 times 5 is 70, and that's where that 70 comes from.
I did
So,
it from the derivative.
Can we just do either one of those?
Yes.
Yeah.
Oh.
So, whoa. But there are times when you don't have a choice. Like, there's no way to distribute x into sine x. You have to use the product rule. So here, you have 2x times cosine x. Or, what if I wrote the 100 exponent? Are you going to multiply that out? No, you're going to use the product rule.
Do you see something to
Yes. Because once you learn chain rule, that's actually a pretty easy derivative.
Is this chain?
No, this is product rule. We're going to take a test after we finish this section.
But is there a difference between product rule and chain rule?
Yes. They're completely different rules. Alright, continuing D. So here, you have sine x times cosine x. Right? So you have two different functions, and you have to do, product rule. There is a way to rewrite this where you don't have to use product rule, but then you have to use chain rule, which is another rule that we haven't covered yet. Alright, so f prime of x, you're keeping the first one constant, times the second one, so derivative of cosine is negative sine, so it's negative sine x, plus, take the derivative of sine x, which is cosine x, times cosine x. So if you were to simplify this, I would rewrite this as cosine squared x minus sine squared x.
What was it?
the end of the
right? Sine times sine is sine squared, but there's a negative there, so put that minus sine squared there. Cosine times cosine is cosine squared.
Well, that's a squared x? Sine squared x?
Yeah, sorry.
It's like a 1.
I mean,
I know, so, that bad handwriting, sorry.
Do you always start with the first?
You don't have to. I'm just following the pattern that was given to us.
Would they ever ask you to simplify that down even more?
Yes,
What happened?
like this is equivalent to,
Minus sine squared.
this is equivalent to cosine 2x.
so, what? You got that cosine x times cosine x? What was that again? What steps?
Okay, so I took the derivative of the first part
Alright.
and kept the second part.
Minus sine squared.
But in the first one, you took the derivative of the second part, kept the first part?
Yeah.
Oh, okay.
How is cosine times cosine squared x, but sine x minus, or times negative sine x, just sine x?
That's sine squared x.
Oh, it is.
Wait,
Looks
how
like
does it
you-
equal cosine squared?
No, that's cosine 2x.
How does it equal to
Double angle formula for cosine.
Oh, yeah.
Is that like 1 minus cosine squared x equals sine x?
Wait, so that's like a.
Alright, cosine 2x.
Coefficient of 2?
Yeah, that's a coefficient of x, not an exponent. Is equal to cosine squared x minus sine squared x. And 2 cosine squared x minus 1. And 1 minus 2 sine squared x. All those four things are equal to each other. So that's just a double angle formula for cosine.
And we're gonna have to memorize
I
that.
don't.
The one you really have to know is this one. But you don't have to know it today. That's not a big deal.
Is
I
there
will
like
emphasize it later.
Is there like a page of just all the,
Trig identities,
yeah,
probably in your pre-cal reference book.
pre-cal what for?
Reference.
The beginning of the code is one.
All right.
Chapter 0.
Sorry.
So the answer would just be.
Yeah, if you just left it cosine squared x minus sine squared x, that's perfectly fine.
Yeah, that's how it would be.
You don't have to switch it to cosine 2x. Someone said, can't that be simplified? And I just did it.
SE.
Do we can leave it like that?
Yeah.
Can we leave it like that on the AP exam?
If it's a free response question, all right, her question was, how can you leave it? So on a free response question, you can leave it like this. Like, you don't even have to multiply that out.
Heck yeah.
You just have to set.
On a free response question, you can leave it like that. You don't even have to multiply the sine times sine.
That's cool.
So what extent on like a free response questions they want you to simplify stuff? Like how far do you
No,
have to
that's
go?
not part of the free response
Okay.
question of calculus test.
Okay.
Simplification is not part of the
So
assessment.
they just want like the first form.
They want the calculus, not the algebra.
Okay, good, thank you.
Not that you're not required to understand algebra, but in answering the question, algebra is not their point.
Good.
Okay, I like that because I mess up on a lot of algebra.
Algebra is all I can do. I can't do calculus.
So
I
what about-
disagree.
What about,
A lot of your questions are algebraic, not calculus oriented. Yes,
what about our test in here? We're gonna have to simplify?
free response questions, I will grade them like AP will grade them.
Yeah.
But is there like multiple choice where they simplify it or something?
Yes, good question. So on a multiple choice, the AP will simplify them. Alright, but they probably won't do anything where it's cosine squared x, so they will probably simplify it to that level, but not to this level.
I don't know.
Okay, but although once you start doing these, this will be natural for at least 30% of you. All right, moving on. So the variable here is s. No idea why they decided to use s. Let's just change it to x.
They probably didn't want to use X.
Well, I get that, but if you change both of them to x, you don't get sex.
We're gonna work out the problem.
All right, huh? So this is product rule. Product rule. So h prime of x would equal x times. So keeping the x. And what's the derivative to the x?
Each of them.
E to the x. So that doesn't change. Plus take the derivative of x, which is 1 times e to the x.
So just to the X.
Yes.
That's all it is.
Yes.
Wow.
Wouldn't it be e to the x plus one, plus x, or plus something?
It's plus e to the x. All right, ready for F? Waiting. That's why I asked.
I'm ready.
So we just leave that as the answer.
Yes.
So what is the x e to the x times 9?
It's x times e to the x.
What's that?
The product is between the x and the e to the x. So the product is x times e to the x. That's not one thing.
But wouldn't it be x times 1?
That's plus.
I don't understand the times one part.
That is the answer.
First, so x times the derivative of e to the x, which is e to the x.
Right. And then the derivative of x, which is 1, times the second function, which is e to the x.
Wait, so e to the x times e to the x is not e to the x squared?
It is not. It's e to the 2x. But we don't have e to the x times e to the x.
Oh, you're not using the product.
We are using the product rule. But e to the x only appears once.
Yeah. Oh, okay.
Oh my gosh. All right. F. So what are the two functions here?
E to the x and sin x.
Right? E to the x is one function and sine x is the other. So it's y prime. Let's keep the first one constant. And what's the derivative of sine?
Cosine.
Cosine
Wait,
x.
just right here.
Yes?
So, find the second derivative. Are you telling me? 'Cause I didn't
If you do second derivative, you just take the derivative again.
See, I thought you were taking. Oh, I thought you were taking the derivative of like the opposite thing that you didn't take. It was the first
It
one.
just worked.
Yeah?
Just do it.
Yeah. Okay. Okay, that makes sense.
Yes.
Why did you make it cosine squared of x?
It's cosine 2x. Are we talking about this one?
Oh, okay. I thought that was like still going with f.
No.
Oh.
Alright. So that becomes e to the x cosine x. So I took, I kept the e to the x constant. Derivative of sine is cosine. Plus, now I take the derivative of e to the x, which is e to the x, times sine x.
That's light work.
What about minus sine x?
No, it's multiple.
No, because I'm not taking the derivative of cosine.
It's light work.
I'm keeping sine x constant. I didn't take the derivative of cosine. Yeah,
E, like the number E is a constant, right?
yes.
Could you do that with like any constant with an exponent?
That's a deeper question than you might think.
Oh.
Oh, that's a good point though. We haven't covered those.
Like if you had pi to the x or something like that.
Right. The derivative of pi to the x is pi to the x times the natural log of pi.
Oh.
Natural law.
Or we just supposed to
Oh, is that
Okay,
only works
so
with-
let's not worry about that right
That
now.
only works with E, okay, never mind.
Alright. So technically, if you use that pattern I just gave you, then technically derivative of e to the x is e to the x times the natural log of e, and the natural log of e is 1.
Yeah, okay, so it's just E, I got you.
What's the natural log of pi?
I don't know. 1 point something?
So then it wouldn't just be pi.
It wouldn't be pi. Because the base of natural log is e. E is not equal to pi. Alright. Okay. G. Product rule. So I'm going to count 4x squared as one function. Okay? So it's going to be 4x squared times the derivative of e to the x. So nothing changes. Plus, now take the derivative of 4x squared, which is 8x, times the second function, which is e to the x. Okay, so h of t. Okay, they really screwed that one. All right.
Wait.
Wait a minute.
Sorry, you're not ready for h?
I know.
Because they put t over here and they put x over here.
So one of them has to be
Well, let's say that's not a mistake. If that's not a mistake, then what's the derivative?
0.
0. Right? So if this is not a mistake, then x is not a variable, it's a constant, so the derivative of that will be 0.
So that's the answer?
No, we're going to assume that's a mistake.
Will there be questions like that?
No. So we're gonna call that x instead of t, okay? Alright, so you could rewrite this as a product. So h of x equals 3x minus 4 times 3x minus 4. So you could either multiply that out or just say, I'm too lazy to multiply it out. I'm going to just treat it as a product. So that'll be h prime of x equals 3x minus 4 times 3 plus 3 times 3x minus 4.
Wait. I get it.
Right? So kept the first function constant just by copying it, then took the derivative of the second function, which is 3, plus take the derivative of the first function, which is 3, times the second function, 3x minus 4.
But multiplying it out is fine.
I think I would have multiplied it out. Because here, like, okay, so if all you're asked to do is find a derivative, then this is fine. But generally speaking, you won't be just fine. You won't just be asked to find the derivative. You'll be asked to say, what is the maximum minimum? You would have to apply the derivative. And this form of the derivative is unwieldy. You want to simplify this.
Oh, I really want to.
Okay? So it would be better to just multiply that out and then take the derivative instead of doing this mess. Okay?
But wait, what if there's more than two things being multiplied together?
Good question. Let's do one like that.
What?
All right, so let's say we have a problem like this. Let's say it was 3x e to the x cosine x. Okay, so now we have three functions, 3x, e to the x, and cosine x. What you're going to do is take the derivative of them separately and keep the other two constant while you're at it. So you're going to take, let's keep the 3x and e to the x constant. So this is the y, oops, just the y, not y prime. So y prime is going to be 3x e to the x, and derivative of cosine is negative sine. So I only took the derivative of cosine. Now, let's take the derivative of e to the x. So that'll be 3x e to the x cosine x, because the derivative of e to the x is just by itself.
That's right.
Now, take the derivative of 3x. So that'll be plus 3 e to the x cosine x. So here's the derivative of cosine. Here is the derivative of e to the x. And here is the derivative of 3.
Wait.
3x.
Wait.
3x, right,
Wait,
3x.
so it's here.
Yes.
So the derivative of sine is cosine, the derivative of cosine is negative sine, and the derivative of negative sine is cosine?
Negative cosine.
Wait, what? Then why is it?
So whenever you take the derivative of sine, sin, the sine, sign, does not change.
What is the derivative of negative sine?
Negative cosine.
So why isn't that negative?
Because I didn't take the derivative of negative cosine. I took the, so this negative sine is the derivative of cosine. This cosine is this cosine copied.
Oh, okay, so you relate back to the original function.
Yes, you always go back to the original. You're taking the derivative of the function, not the derivative of the derivative, as you're taking the derivative. Did you understand that?
Yeah, I got
You
it.
always go back to the original.
I kept doing like what I was just.
Yeah, I understand.
Oh, so you do the same thing and then add the original again?
Yes.
Wait, so sine
Whoa.
is negative sine?
When you say add the original at the end, what does that mean?
Well, like, go back to it.
Right, so you go back to the original.
Yeah.
But then I took the derivative of 3x, which is 3, and then copied the rest.
Oh, okay.
Alright?
Oh, yeah.
Okay. Quotient rule. Quotient rule is related to the product rule, but it looks very different. In the product rule, because it's a sum, the order does not matter. In the quotient rule, it's a difference, so the order will matter. Okay? Alright, so here. So, quotient rule is frequently like you have to do it. I mean, there may be times where you don't have to, but none of the examples here gives me a second option. All of these require the quotient rule.
Right.
Although some of you may prefer the product rule to it, and there will be a way to sneak around that and use the product rule instead of the quotient rule. And that's applicable to one of these. Yeah, like you could switch it to a quotient product rule instead of using the quotient rule. But all of these require the quotient rule.
Is it C?
Yes. Alright, let's zoom in on this. Alright. Okay, so let's apply the quotient rule. Let's look at what we have. Alright. So this is a classic, what's the word? Way to remember it, right? So you have a derivative of high over low. It would be low D high minus high D low over low low. Okay, so, alright, here we go. So let's take the derivative.
Someone probably made a song out of that.
Yeah, somebody did. Alright. So we're taking the first derivative. So this is the way I remember it. I always bring the numerator up. I always bring the the denominator up. I bring the denominator up times the derivative of the numerator minus, why did you put so little space? And she didn't order space.
There's no space to do
Look, she put all this space here when the derivative needs the space. What is it? This is Alright. So I bring the denominator up. Bring the denominator up. I bring the bottom up.
Yeah.
Times the derivative of the numerator. Minus derivative of the denominator times the numerator. So it's 1 times 2x minus 2x plus 3.
So the denominator's on the bottom?
Denominator's on the bottom.
Minus what?
Is that 2x plus or minus? Well, it would
Where
be
are you?
The second one top.
Here?
Yeah, but it
That's a
should
plus
be-
sign.
But it should be minus the second one.
If you distribute it, yeah. Huh?
How can you bring x minus 1, or how can you bring the denominator to the numerator without changing the amount of the denominator?
Because it's the rule of the quotient rule. It's just a quotient rule.
I gotta get.
It's just the rule. It's like, that's how you take the derivative. It's not, I didn't do algebra. I did calculus. So that's a calculus rule that allowed me to do that. Alright, ready for B? I'm leaving that alone. You want me to simplify that?
No.
Alright.
So that's all you have to do? Oh.
When all I'm asked to do is find the derivative, yes.
What is the second part of the numerator? Is that minus 1?
That's minus 1 times the quantity 2x plus 3.
Yeah.
Ready for B?
Yes, we're ready.
Alright. See, we could have put the line here.
Just make a new line. Yeah.
Alright, so I'm ignoring this line. So I'm going to write through that line. So it's g prime of x equals, bring the denominator up, so it's x plus 2. What's the derivative of the numerator?
1.
1. So times 1. Minus derivative of the denominator, which is 1, times the numerator, which is x, over the denominator squared.
X plus 2.
Hmm?
It's not working. Okay, next one.
Let's simplify that one.
Ah.
No.
Wait,
Oh wait, well x plus 2.
how is
Never mind.
I'm listening,
how's
Brandon.
the derivative of the bottom just x, not 1?
No, it is 1. X is the numerator.
Oh yeah.
Okay, but if you simplify this, you just get 2 over x plus 2 squared. Right? The x minus x cancel, you just have 2 left over.
You can simplify the denominator,
Oh,
right?
I see.
Okay, that would be expanding the denominator, not simplifying.
Okay.
Oh, okay.
I understand
The x is cancelled. Wait, why are you simplifying them? We haven't done that.
Because I want to.
Okay. Right.
Alright, ready? Ready for C?
Can we change this
Yeah.
to x?
Huh?
Can we change C to x?
Sure.
simplify it further? Or is it?
I don't want to. Anything else is not really simplifying. That would be expanding.
Right.
Alright, C.
Gets bigger.
To me, the factored form is the best form. Right? So that'll be a factored form. Alright. C. Let's get over that. Alright. So someone requested change these to x's. I agree. Alright. So let's take the derivative. Ooh, let me throw that line. So h prime of x equals, bring the denominator up, that's an equal sign there. Bring the denominator up times the derivative of the numerator, which is e to the x, minus derivative of the denominator, which is 1, times e to the x, over x squared.
Okay, we're leaving it.
Do you have to do the derivative before the?
Wait, I have a question.
Hold on,
Bring it
someone's asking a
low up.
question. Say it again?
Like, do you have to put the derivative before bringing the low up all the
Minus
time?
1
Like,
is there.
I don't understand the question.
could you do?
I'm
e to
taking the
x?
derivative.
Yeah,
Huh?
but like, could you do e to the x times -1? Like,
No, you do have to follow that order because of that minus sign, right? You can't say it's minus xt to the x. So if you wrote this as e to the x minus xt to the x, you have a sign error.
but you'd still have the minus sign though.
Right, but it's in the wrong place.
And then,
It's like saying 1 minus 2 and 2 minus 1 are the same,
so that's how you got both of those equal x.
right?
But you're multiplying, like, no matter what, e to x times 1 is going to be 1. Why does it matter
Right,
where
but
the-
that one has to have the minus sign.
Isn't the minus sign always in the quotient rule though?
Low to high.
Yes. So that's why but it's always on the second pair.
Low square.
If you
Yeah.
remember where the minus sign goes and you don't care what order to do it, then that's fine.
You did like, so the original of the bottom times the derivative, and then the derivative times the original.
Okay,
Like,
you need to be more specific in the second part. So you bring up the denominator, so it's the denominator times the derivative of the numerator minus the derivative of the denominator times the numerator, right?
it's irrelevant.
Alright, D.
So that's a question.
Let's change it again to x's.
This is question.
Yes.
For the quotient rule, you just bring up the denominator and multiply it out by each term. Like for the-
No. So you bring up the denominator, right? Bring up the denominator. So that's sine x times the derivative of the numerator. So it's not multiplied by each term. It's multiplied by the derivative of the numerator. So that would be 3x squared. Minus. Now take the derivative of the denominator. So the derivative of the denominator is cosine times the numerator, which is x cubed,
I agree.
over sine squared x.
Oh, I get it now.
Sine squared and x and sine x squared. I think are the same, right?
Yes. Let me address that real quick. So his question was, this notation is equivalent to this notation. And yes,
What
that
happens
is,
if you leave it like sin x with parentheses and stuff?
that is perfectly legit.
Okay.
And if you never write it this way, ever, that's perfectly legit. Just be able to recognize it when it's part of a multiple choice answer.
Maybe.
Wait, so what's gonna be minus, right?
Say what?
Like, you know, say sin x, times 3x squared minus. I think that minus sign goes to it.
Huh?
That minus sign.
That's part of the quotient rule.
Okay, okay, sure.
Right. It wasn't negative cosine, was a derivative. Minus sign is part of the quotient rule. Yes.
Okay, my question was, like, is there a reason that you put the negative or put the cosine before the x cubed?
No.
Okay, then,
Right. So multiplication is commutative. So that order does not matter.
So that's what you
All right. So if you switch this order, that's perfectly fine. As long as you realize that this first term has to have the denominator. Okay? Alright.
make it simple. That's basically just called over.
Page 102.
Show you how much truth.
Yes. Yes. Alright. Moving on.
Whoa.
Okay, so you might think This is a quotient rule. But the denominator is just a number, right? So we can rewrite this as 1/6 x squared plus 1/2
You're lagging, man.
x.
You're lagging.
Wow. That was weird.
What?
Okay, so I simplified this expression by simply dividing each term by 6. So that was 1/6 x squared plus 1/2 x. That looked like real life lagged.
Yeah, you're lagging.
All right. So take the derivative here. So you just use power rule. So that's going to be what, 1/3 x plus 1/2.
Yes. This is not easy,
Yes.
but it'll get hard.
Not really. Well, I guess it does. All right.
So this is basically
Yes.
saying you don't have.
All right. So you're asking what happened since I have half x here. How do I have a half here? That's your question?
Yeah.
All right. So when you use the power rule on that, what is the exponent on x?
I can see.
What's the exponent on x? If you don't see an exponent, what's the exponent? 1. Right? So it's x to the first power. So if you use the power rule, it's 1/2 times 1, which is 1/2. And then you subtract 1 from 1, giving you x to the 0. And anything to the 0 power is 1.
Is that what happened for 1/3 too?
Yes.
Okay.
So it was 2 times 1/6. That reduces to 1/3. Subtract 1 from the exponent, give you x to the 1.
Okay.
Alright? Alright. So that was straight power rule. Now let's go on to B. Right? You good? Alright. So I am going to rewrite this by dividing through by the x squared. So that's going to be 5x plus 3 minus 7x to the negative 2. Then you just apply the power rule.
Wait, x to the negative 2.
So that would be 5 plus 14 x to the negative 3.
Yeah.
So then you just took the derivative of that. Okay.
Yeah. So you didn't have to use the quotient rule.
So this is all saying that it looks like you should use the quotient rule, but you don't have to.
Yes. Brandon's question was, what are the purposes of these examples? The purpose of these examples is, if you don't want to use the quotient rule, see if you can find a way around it. Right? So this one, you can do some algebra, do the division, and you can avoid the quotient rule.
Is that the same as 5 over 14x cubed?
Where are you?
Wait, no, it isn't.
It'd be 5 plus 14 over x cubed.
I have an actual, like, it's like a real life question that goes with this. Like, what job is this used for? Like
Engineering.
Yeah.
Like doing what specifically?
Find the rate of change of something. For example, car movement, right? How fast the piston moves, how fast the wheels are turning. You got rotational speed of the wheel, steering wheel, rotational speed of tires, weaponry, how to shoot weapons, how the velocity of your bullets, velocity of a rocket, how fast something drops from the air, airplanes, the rate of change or the fuel consumption.
What's the derivative of 3?
Catapults.
Yeah.
It's most engineering kind of stuff requires
The
this.
derivative of a constant 0?
Now, but there are engineers who are they're the grunt work, so they probably don't have to do this. But then there are those people who have to actually make the designs and make sure things work properly, and they would have to do this.
Aren't they architects?
Architects build stuff that don't move. Engineers build stuff that move. And this is what this is more related to. Things that move. Now, that doesn't mean that architects don't need to do this, but it's probably a smaller part of their job than it is in engineers.
Yes, basically it's useless.
Is there anything on this earth that doesn't move?
Say what?
Anything on this earth that doesn't move?
Civil
Math.
engineers build stuff that
All right, ready? C. Let's go on to C. All right, so I'm going to rewrite this very strangely. I'm going to make this negative 3/7 times 3 minus 2x.
What
Where did
the X?
the X go?
Where'd the X go?
Where'd the x go? Minnesota.
Brazil?
Oh, no!
They just cancel, right?
Is it minus
Brazil is not accepting American imports.
Is it minus 4x?
Alright, so I divided by x. 3x over x, the x cancels.
Is it fine?
X squared over x
Oh, the
becomes
X
x.
canceled. Okay.
Is it fine if we just multiply the numerator?
Uh-huh. Again?
Is it fine if we just multiply the numerator and then divide it?
Yes. That was a constant, so I decided to just leave it out there. So when I take the derivative, that constant just stays out there, and I take the derivative of negative 2. Negative 2x, so that's going to be that. So that is just 6/7. That was rather disappointing.
So where did the 9 go?
Minnesota. Where did 9 come from?
I think I distributed on top and then figured out X and then it was...
Alright, you want me to do it that way?
Yeah.
Alright, so if I do it that way, I get y equals negative 9x plus 6x squared over 7x, right? And if you want me to divide that through, that's going to be negative 9/7 plus 6/7 x, right?
Yes.
And then, so when I take the derivative of that, the negative 9/7 goes away, and I just have 6/7.
Oh, because it's a constant? And the constant is...
Yeah.
Literally. Oh.
That's pretty easy.
Yes, but this was more entertaining. Yes.
I have a question for the AP then.
Okay.
So, when do they want you to use like the rules, and when do they want you to kind of work it out, like for power rule and all that?
You can use whatever rule is appropriate at the time.
Okay.
There's never going to be a problem that says you must use the product rule. It'll simply say find the derivative.
Okay, good.
Okay. So there is nothing on the AP test where it requires you to use a specific technique.
Okay,
Okay.
that's good.
Wait, so even, oh wait, no.
Now, so like even if you know something really weird and use some kind of geometry technique, as long as the math is correct, they don't care.
But are they gonna ask us for the limit definition?
Yeah, for
They will. It's not like a vocabulary test. So it'll be like a multiple choice question where they give you the limit definition of the derivative of sine at pi over 4. Now, if you realize you can use L'Hopital's rule on it instead of using the limit definition, you can still answer the question properly.
So we can still, like, we're never gonna have to use that super long process to find the derivative?
There's not a have to for anything other than using calculus. So whatever calculus tools you have at your disposal, you can use that tool.
So they just made you teach us the long rule first, just...
Yeah, but sometimes you can't avoid that rule.
Yeah, sure.
Alright.
which I don't know when, but I'll find out.
Alright, so this one, I am going to just treat it as 1/8. So I'm going to treat it as 1/8 times 3x plus sine x minus e to the x. So g prime of x equals 1/8 times the derivative of that. So that'd be 3 plus cosine x
Oh, this is
minus e to the x.
Wait. So is that 1/8? Like
Yes.
anything over 8? Where did 1/8 come from?
That's not
It's on right there.
I'm doing that. Where the x goes 3x?
What's the derivative of 3x?
0.
3. Derivative of 3x is 3.
It was a 3 and then a closed bracket.
This makes me.
Alright.
And that's it?
No. I'm just checking the time. Ooh. So, Trig. Ooh, there's homework.
No! What?
In fact, let's stop there and sign the homework. Alright.
Textbook?
Yeah, it'll be textbook. What happened? Oh.
Monday, Mr. Sledge.
Congratulations, it's Monday. Uh-oh, what happened to my computer? There we go. All right.